Where is Gabes? He said he'd meet us here.
Is that your phone?
Hey, it's Gabes!
That was nice of him.
But how do we find the street he's talking about?
Well, the main road runs from north to south, so west should be on that side.
But there are many streets on that side of the main road. How do we know if the street is parallel to the main road or not?
Let me think about it for a while.
Does anyone know how to help these students?
Ma'am, I learned from geometry class that if a line crosses two other lines at a certain angle, then those two other lines are parallel.
That third line you were talking about could be perpendicular to both, right?
Yes, ma'am.
But we're talking about streets here. How does that help them?
You'll see.
Ah, I know. Look at that road that leads west. It's perpendicular to the main, right?
So,
So, all we have to do is find another street that is perpendicular to that street heading west.
oh, I see. Let's go then.
Hey, walk on the left side of the road so you can see cars coming towards you.
Oops, sorry. Is this it?
No, it's not perpendicular to this road we're walking on.
This must be it then.
You're right. It is perpendicular to this road we're walking on.
So this road must be parallel to the main. Hey guys, over here! Hey, have you guys seen music?
Apparently, the two had the same idea. Now, I've taken the liberty of representing these streets as lines on the coordinate plane. Which lines are perpendicular and which ones are parallel?
Ma'am, line 3 is perpendicular to both lines 1 and 2.
And lines 1 and 2 are parallel.
You're both correct. Now, could someone give me the equation of each line?
Let me try, ma'am.
Okay, go ahead.
Let's see. Line 1 has a slope of 1/2 and intersects the y-axis at 0 and -1. So, the equation of line 1 is y is equal to 1/2 x minus 1.
That's right. How about the rest?
Well, the equation of line 2 is y is equal to 1/2 x plus 2. And the equation of line 3 is y is equal to -2x minus 1.
Good job, Denise.
Ma'am, I just realized something.
What is it, CJ?
Lines 1 and 2 are parallel, right?
Yes. And so?
Well, they have the same slope and different y-intercepts. And lines 1 and 3 are perpendicular and their slopes are not equal. It looks like they're negative reciprocals of one another.
You're right. In fact, your observations are valid for all parallel and perpendicular lines. All parallel lines have the same slope, and the slopes of perpendicular lines are negative reciprocals of one another. So, if you're given a line with a slope of -2/3, what will be the slope of a line perpendicular to it?
Positive 3/2!
Very good! So we've seen lines that intersect and we've seen lines that don't intersect or are parallel. What else can happen when we try to graph two lines on the coordinate plane?
But what else is there?
Everyone, go get 2 pencils. Now, imagine that these pencils are the lines and your desk is the coordinate plane. In what ways can you place your pencils on the desk?
All I get is either they intersect or they don't.
Oh, I can place one pencil on top of the other. So one line can lie on top of the other line.
You got it! So, given any 2 lines on the coordinate plane, only one of 3 things can happen. First, they can intersect. Second, they won't, since they're parallel. Third, they coincide, meaning they lie on top of one another. Now class, when we consider 2 or more linear equations together, we have what we call a system of linear equations.